Vectors, question 1. The diagram shows the forces acting on a stationary kite. F is the force due to the wind, T the tension in the string, and W the weight of the kite. Part A. If the tension T is equal to 20 newtons, calculate the horizontal and vertical components of T. Well, the horizontal component will act in this direction, and I've labelled it T sub h, and this will be given by 20 sine 35 degrees, as we're going away from the angle we've been given. This has a value of 11.5 newtons. The vertical component will act down here. I've coloured it blue so it stands out from the weight, and I've called it T sub v. Here we're going across the angle, so T sub v, the vertical component of tension, will be 20 cos 35, which is 16.4 newtons. For part B, we're asked to show the vertical and horizontal components of F on the diagram. Well, the vertical component will act directly upwards, and we'll say it acts at an angle theta from F. And so this will have a value F cos theta, as we're resolving F across the angle theta. The horizontal component will act in this direction, and we're resolving away from the given angle, so this will be F sine theta. Part C. If the kite has a weight of 2.0 newtons, find the vertical and horizontal component of F. Well, we're told that the kite is stationary, and so F cos theta, the vertical component of F, must equal the vertical component of tension, T sub v, and the weight. So we can write F cos theta is equal to T sub v plus W, where T sub v we found here at 16.4 newtons, so I've put that here, and the weight we're given at 2.0 newtons, giving F cos theta equal to 18.4 newtons. Also, we can say that the horizontal component of tension will be equal to the horizontal component of F sine theta. So we can write F sine theta is equal to T sub h, which we found previously at 11.5 newtons. So that is our horizontal component of F. For part D, we're asked to find force F. Well, we know that the vertical component is 18.4 newtons, and we join onto that, tip to tail, the horizontal component at 11.5 newtons. The resultant then goes from the start to the finish, and that will be our force F. By Pythagoras, we can find that F squared is equal to 18.4 squared plus 11.5 squared. So F squared is equal to 471 newtons squared, and so F will be 21.7 newtons. We've not yet finished, because forces are vectors, so we must also state the direction. So if we call this angle theta, as we did on the previous diagram, then tan theta is equal to 11.5 over 18.4, giving theta at 32 degrees. So we can say that F has a magnitude of 21.7 newtons and acts at an angle of 32 degrees to the vertical.